whenever you are designing any indexing system for finding the required posting list for a given term or for a given phrase, it may happen that whatever the entry is given by that particular user, that may not be written correctly, or whatever the spelling is done by that user, it is wrong. So in that case, how your indexing system will be able to handle, or how your indexing system will be able to retrieve the documents or the proper documents for the given term or written term. So somehow I have completed in the last class. Am I audible and my screen is visible to you? Do just anybody respond?
Yes, sir.
Yes.
Yes, sir.
Okay. So in the last class, we already discussed about the spelling correction, that there are two flavors. One is that where that particular term or the word is being corrected isolatedly, irrespective of the surrounding, irrespective of the atmosphere where it is being written. Such as, suppose you have written the spelling of college instead of college, it is written like this, college, which is wrong, and you are being correcting by the help of a dictionary. But it is not the case for all the situation where we have to maintain or we have to write the proper word though it is written correctly. Look at the second case, that is context sensitive, because the term FROM as well as FORM both are correct. As in dictionary, both are correct, FROM as well as FORM. But this meaning of these two terms are different. Depending upon the situation, you have to put the proper word or proper term. So the phrase is like this: I flew, written as FORM form, Heathrow to Narita. So it is one place to place. You are moving from one place to another place. That is why it must be FROM, but the user has given FORM, which is wrong. So in these two scenario, you have to perform the spelling correction, either in case of isolated word or in case of context sensitive. You are getting the words or documents or terms in two ways. This thing also I have told, that you are getting the text by typing something through the keyboard, or else you are retrieving some text from the text images. The two ways or two approaches. So when you are typing something, that the keyboard is called QWERT, just in basically whatever the keyboard you have in your laptop, that is called as QWERTY keyboard. And the other way is that there is some text images from which you are retrieving the text, that is called as optical character recognition or OCR. So first case, suppose you have retrieved the text from a document images. In that case, it may happen that that particular character D and O are pretty similar. You may see that the character D and O are pretty similar, and instead of retrieving D, you are retrieving O, and in case of retrieving O, you are retrieving D. It is a confusion, it's a mistake. So when you are retrieving through the OCR engine, you are confusing in between the O and D. Similarly, when you are typing some text through the help of a QWERTY keyboard, our laptop keyboard, so in that case, you may confuse among the O and I, because just look at this keyboard of your laptop, that O and I or IO and O are very closer. So when you are typing, by mistakenly, instead of typing on I, you have typed on O, or in case of typing on O, if you have typed on I, it is getting confused. So in those scenarios, in this kind of situation, the spelling may misspelled. Okay. So these things, due to which the spelling mistake or the misspell occur in case of writing that query or typing the query on the search engine. So those though this kind of situation occur, that means the spelling is being mistake, or you have written a wrong spelled word or term. How in situation your indexing system or inverted document term indexing system will be able to retrieve the correct posting list or document list, because our objective is to retrieve the proper document or retrieve or getting the proper posting list of the documents in any situation, in any worst situation, though it may be the terms or the words are correctly written, or it may be the words or the phrases are wrongly written. Then also how your system or how your indexing system will be able to manage this kind of inputs. So this is also, suppose a query is being given like this, you may pronounce this kind of words what is being written. Anyhow, the query, assume that this query is wrong and the terms are being written wrongly. So in that case, what can be done? One approach is that make it correct as per your knowledge, or the analyze the query whether it is wrong or correct. If it is wrong, then make it correct, and depending on that correct query, get the posting list or get the document list. It is one approach. Second approach is that whatever the query is given to you, as you used to do done by the Google, you suggest some alternative queries. Did you mean this one? Did you mean this one, like that? So whatever the particular query is being selected by the user, depending on that, retrieve the posting list. Okay. So these are the two approach. You can do any one of them and retrieve the required posting list from the corpus. So as I have told, the first approach, that was isolated word correction, where you are not bothering about the surrounding. Whatever the phrase is, that you are not considering the all total number of words, rather you are considering on a single term, a single word. You are concentrating on a single word. How? By maintaining a lexicon or dictionary. So this dictionary can be an English dictionary. You may have an English application type dictionary, or else you may have maintained a handmade or human made lexicon, depending upon the industry specific oriented or industry oriented dictionary, depending upon what are the different products are being developed or they are created by that particular industry, so that you are building that kind of lexicon. So whenever you are finding any words or any terms related to that, whether it is being wrongly written or by mistakenly the words are wrong, at the time you can choose the proper word from the dictionary and give to the user end. Okay, so this thing can be done by a dictionary or by a lexicon. Both the things are same. Otherwise, you may have some synonym. This thing I will tell you later. You may have some synonym. Suppose that particular term is not exactly matching with your corpus, but the similar terms or similar words are matching. In that case, you can maintain that lexicon because it is handmade by you or by any human being. At the time, you can retrieve some responses which are exactly not matching with the term. Rather, some of the synonyms or some of the related terms are matched. That is why you are providing that particular posting list onto the user end, though it is being misspelled. So the first one, where it is word being corrected by in the isolated form or an isolated location, at the time you may use several alternatives or several techniques to make it correct, because you assume that you found that whatever the terms or words written by that particular user may have some wrong characters, or it is being written wrongly. So what are the different ways that can be done or that can be adapted to make it correct? That is, one is, the first is edit distance approach. The second is quite related with this edit distance, is called as weighted edit distance. And the third is n-gram overlap. First come to the edit distance. How this edit distance will help you to find the correct word instead of the misspelled word. First try to know what is this edit distance. Basically, edit distance will help you to what? To find the dissimilarity existing in between two strings. Means whatever the entries given by the particular user on the search engine for finding the correct posting list, that entry to the search engine is nothing but a set of character, or it's a string. So this edit distance will help you to compare the two strings. Compare the two strings. So how this comparison can be done? By the help of some basic operations. What are those? Insertion, deletion, as well as replacement. One is called as insertion, another is called as deletion, another is called as, third is called as replacement. So in between the two string S1 and S2, if you are going to compare by the help of edit distance, how you can do that? By calculating the number of insertion or number of deletion or number of replacement. That is being done with every character of that two strings. Take an example, cat and dog. So if you are going to compare by the help of edit distance, that what is the distance between these two number of words? The number of distance will be high, means both the terms of both the words are very different. And if the distance is very low, that means near to zero, that means these two terms are very similar and maybe same. So the terms, one term is cat, CAT, another term is dog, DOG, and you are going to find the edit distance in between these two strings. So I can say that to convert the term dog into cat, I need three replacement. That is D to C, O to A, and G to T. There are three replacement I need to do to convert the term dog to cat. Assuming that this dog is written as wrongly, and which is the correct term, that is as cat. Suppose the term is written as first, that is correct term is cat, but the user is written CUT, cut. Though these two things are correct, forget this correctness, you just find what is the edit distance in between these two terms. Easily you can see that the last term is T, which is correct, no replacement or no changing or no deletion is there. First term also same, C and C, no insertion, deletion, replacement is there. Only one, that is that intermediate character, that is A and U, which is need to be replaced. So U needs to be changed. That means the edit distance value will be 1 in between these two terms, cat and cut. Okay, so by the help of which you are able to find which particular term is very much closer to which particular term. So if you found that due to some reason that particular term is not matching with your posting list or is not matching with the corpus, then whichever the rest word or term is matching correctly, that is my cat. So if the distance between these two characters is these two words is very less, I can assume that the correct word is cat instead of cut, because this cut is not present in your corpus, it is not existing in your database. That is why you found that the correct word term is cat by the help of this edit distance. So you can go through this link to get some more idea about this edit distance. Another thing, so how to build this indexing system by the help of this edit distance? What should be my algorithm? What should be my technique or logic to build this correcting of words or terms basis of edit distance. In this case, your algorithm or your technique or methodology is to be maintain a weight matrix. Maintain a weight matrix. You have to maintain a weight matrix. Again, two things. When we are going to maintain this weight matrix, you need to consider two situations, two scenarios. What are those? As I have told earlier, one thing, you are going to type the character or the terms by the help of your keyboard, or else you are retrieving the text from the OCR engine. Depending on these two situations, depending on these two scenarios, the weight matrix will be different. Try to understand. Your weight matrix will be different. Okay, so again consider the same previous example. The character D, character O, and character I. So if you are typing the text by the help of that keyboard, that means that distance between D and O will be more, whereas distance between O and I is very less, because you are typing through the keyboard. Because the distance between, look at your keyboard, laptop keyboard, the distance between the term D, character D and O is very high. So it is very less probability of typing O instead of D, or typing D instead of O, because your finger will never jump from D to O, because O is very far away from D, as well as D is very far away from O, vice versa. So when you are typing through the keyboard, in that case, the distance will be more in between the character term D and O, whereas the letter O and I very closer, very similar. So I can maintain a weight matrix based on the basis of this, that the distance between these two terms or these two characters are very less, because I have typed through the keyboard. So if the matrix is like that, assume that D, O, and I, and again the column side also, row side also, D, O, and I. In that case, you can say that D to D, let it is 0, whereas D to O is very high, and D to I is little less. In that case, you can maintain for all the possible characters. So now come to the OCR engine when you are retrieving in the second case, through the second case. In that case, again you have to maintain a weight matrix depending on the similarity existing in between two different characters. We find that D and O are very similar. So maintain a weight matrix depending on the similarity in between the characters. It can be collected by running a OCR engine. By running a OCR engine, it will tell you that which particular characters or which particular letters are confusing. Okay, so by the help of which you can build the same kind of matrix, but where instead of maintaining this kind of keyboard distance, you have to maintain a OCR in the difference or dissimilarity existing between two characters based on the OCR engine. So is it really going to help you, this kind of approaches, by maintaining the weight matrix, maybe through the keyboard or maybe through the OCR engine? How much it will help you? Probably this will help you, but cannot be really fix your problem. Very slow, because you are going to maintain distance maybe through the OCR, maybe through the keyboard, for every word to every word, or every term to every term. So process is very slow. Anyway, but it can help you. It can help you to predict the correct term or predict the correct word or predict the correct phrase also, because we may think that and we may found that whatever the entry given by the user is not correct, or else it is not matching with your corpus. In that situation, how you should manage, how your indexing system will able to retrieve some kind of responses from the database or from the corpus. So you can use this kind of approaches. So one that I have told, that is edit distance. Another I have told, that is weighted edit distance value depending on the OCR as well as depending on the QWERTY keyboard. The third thing was, that is based on n-gram overlap concept. N-gram overlap, because what we found till now, that edit distance is helping us, but it takes very huge time or to compute the matrix, weight matrix for every word to every term, because your corpus may have 1 million number of words. So 1 million number of words in the row side, 1 million number of words in the column side. It is huge. Matrix will be very much large. So another approach is that is n-gram overlap concept. It may help you again the same thing, whether that query given by the user is misspelled or wrongly written, and you are going to predict the correct word or correct term, depending upon the words or terms you have in your database or your corpus. So it is very similar. Already we have known about this n-gram indexing technique in our previous wildcard search. Again, I will tell you by the help of example that first of all you have to break your whole word or the whole query given by the user as well as you have in your corpus or in your indexing system into several number of words or several number of terms or several number of fraction of words by breaking those words into possible number of n-grams. Your n-grams may be a one single character. Your n may be 1, 2, 3 or 4 depending upon your word length. This n will go up to how much? Depending upon the word length of the given query. So take an example where we have chosen that n-gram, that is 3, that is trigrams. We are going to find the n-gram overlap in between the two words where n I have taken 3 or trigrams. So the fundamental idea is that instead of comparing with the all words with a given query, instead of comparing with the all words for the given query, we can compare with some limited number of terms or words, so that it can help you to reduce the time complexity. Those particular words which are having a huge overlap means very similar, huge overlap, only that kind of words I should compare, instead of comparing those words which are very dissimilar or do not have any overlap in between them. Have you got the concept? Look at these two example. One example, the suppose that query is given by the term user, that is November, but due to some reason that query is given by example is query is given as December, but we have the text November, we do not have December. So how to know that that particular user is asking about November instead of December, or we should trying to show the so we should show the posting list based on this November. First of all, we need to find out how many number of terms are overlapping in between these two terms, November and December. It's a small example, may not be the same things will come across in your question. So as it is trigram, try to break the whole word into possible number of 3 characters, overlapping 3 characters. One is NOV, another is OVE, another is VEM, another is EMB, another is MBE, another is BER. These are the 6 possible trigrams. Similarly, you are going to find for the next term where you are going to find the comparison. How much similar or dissimilar in between these two words. Again, you are finding the possible number of trigrams for the second term or second word. So what we found that out of these 6 trigrams, 3 trigrams are being matched or overlapped. Here also there, and in the second queries also, we are getting the same number of same trigrams overlapped. So depending on which, you can make it some normalization. I will tell you how to make normalization. You can make some normalized, and you can maintain the matrix, or else you can maintain a array that this particular term is very much how much it is similar or how much being overlapped with this particular term. So in that case, one basic idea that is called a Jaccard coefficient is being used. It is very much well-known application, Jaccard coefficient, to find the similarity or overlapping in between the 2 strings. What it tells, x and y, where x is the set of number of n-gram. As it I have taken trigram, that is I am telling you trigram, or you can take any of the size of this n. So the number of trigrams of the first string and number of trigrams of the second string, or number of n-grams of the first string, number of n-grams of the second string. Find the common intersection. What we got here, that is 3, November and December, and x union y. X union y will be how much? It is 6 and 3 common plus 3, 9. X union y, that is will be 9. So what you are going to calculate? You are going to calculate 3 by 9. Whatever the value. Whatever the value, that will be the Jaccard coefficient value. So you can make it threshold that whenever you are having a Jaccard coefficient value more than 0.8, at the time you should consider that particular one may have that is similar with a given query. Otherwise, you can ignore that. So if it is much more similar, that particular first string and the second string, if these 2 strings x and y are very similar or same, in that case, what will be the output? That will be 1. And if there is no common, very dissimilar, it will be 0. So the value will be lies in between 0 and 1. If it is much more similar or very same, that will be 1. And if it is totally dissimilar, it will be 0. So we can make a threshold that whenever my value will be 0.008, greater than 0.8, greater than 0.8, at the time that particular 2 terms, November and December, I can consider, or else I can ignore. There is no meaning of considering such a word which is having or which is secured or acquired less than 0.8. You can we can make an algorithm like that. Instead of going through all the possible number of words to make a comparison, make a matrix, you can do like this. Again, one more example. Suppose you are going to find the possible posting list for the given term LORD, Lord. Okay, so as this term is very small, I have taken a 2 gram or bigram. So what are the possible combination of this given term LOD? That is, one is LO, another is OR, another is RD. LO, OR and RD. Okay, so what are the different words that is having LO? One, this one, this one, this one. What are the terms between having OR, and what are the terms what are having RD? So whoever the terms are matching or having higher number of overlap or higher number of bigrams, that particular term I need. The rest I should discard. And again, you may apply the Jaccard coefficient. If it is securing more than 0.8, I can consider. Whoever securing more than 0.8, I should consider. The rest I can discard. I can ignore. So how this algorithm will work? As you have done earlier, always you should start from the beginning, or you may start from ascending from smaller alphabet to larger alphabet. That means start from A, then B, then C, then D up to Z. So first of all, the first alone A, only one matched, that is LO. And whether I have found this OR and RD? No. Then come to the ardent, or the first first word of this third line. It is only RD is matched. Only RD is matched. And nothing, or no more number of bigrams are being matched. Then come to here. That is OR. That is OR. Here also OR. This particular term occurrence is twice. Here having OR and here having RD. Two bigrams are matching. Two bigrams are, that means this border is pretty similar with the LOD instead of choosing alone or ardent. Instead of choosing alone and ardent. Because in alone and ardent only one bigrams are matching, whereas in border we are finding or overlapping two number of bigrams. Got it? Then A completed, B completed, then come to the next C. C, that we are finding the term CARD, and we find that only one particular bigram is matching. Ignore that, because we can think that which were having at least two number of matchings or overlapping, I will consider that one, and the rest I should discard. Then after that we are getting L, A, B, C, then L, where we are finding that LO is matching, OR is matching, RD is matching, and here also LO, OR, RD, three matchings we are finding. So it can be another solution. One can be solution border, another can be solution LORD. In the third case, here also we may have LORD, because A, B, C, then it may have LORD. So here it is matching, here it is matching, here it is matching. All the possible number of bigrams are being matched with the word LORD here. So it is better solution, optimal solution. Okay, then A, B, C, L completed, then come to the next M. Only OR is matching, one bigram is matching. So you can ignore that. After completing M, then come to S. SLOTH, only LO is matching. So only one is matching, forget that, ignore that. So what we found, we are choosing only those words or terms which are satisfying at least two match out of the three bigrams. So depending like this, you can build your own algorithm, own technique, so that match the proper or very closer term for the given query term, so that you can build your edit distance matrix or weighted edit distance matrix basis of this one, instead of computing the edit distance in between all the possible all the words. No, there is no need of building the edit distance in between all the words. Rather, you can choose the very related terms. Adapt this using the Jaccard or another measure. You can do like this, 2 out of 3, or else you can use the Jaccard coefficient concept. How much it is matching and how much total length, make it division, and it will give you some floating value in between 0 to 1. Higher ranking means higher similarity, lower ranking or 0 means dissimilarity. It is all about isolated word correction, then come to the context sensitive scale correction of word correction. That example was very common that we have already told. I flew from one place to another place, Heathrow to Narita. So whether it is FROM or FORM. So how to respond in this kind of phrase queries? Because the query is being given by the user is FORM. But you should respond the correct query as it is flew from FROM. Because whatever the entry given by the user, flew from Heathrow, it is exactly not matching with the given corpus, or you have whatever the number of documents in your database, because no such documents are matching with the given query. So you should suggest that this particular possible query, whatever the given by the user, instead of flew from. So how to do that? How to know that exactly what kind of solution, what kind of query is being required by the user? Because the user, we're assuming that the user has entered some wrong entry or some misspelled text or phrases. So you can have different number of words from the given phrase. One can be this one can be this one. Assume that there are 3 terms in the given phrase. So we can maintain a weighted addition matrix. If this is wrong, it is similar with which one? If this is wrong, it is similar with this one, and if it is wrong, it is similar with which one? And then you are finding the correct terms or words, though it is being misspelled by the user. Then you are suggesting the proper response, proper query. You can suggest some alternative, correct alternative, or else whatever the alternative are suggesting that may have highest hits or very large hits. Suppose you are Amitabh, you are typing the text Amitabh Bachchan, but suppose you have written by mistakenly, instead of Amitabh, ABH, you have typed AMITAV, and instead of Bachchan, you are typing only BACHAN. So these two are wrongly written. So in that case, what will happen? If you just you can check it. When you are writing this the same term in your Google search engine, it will suggest some alternative, the correct alternative. That means which particular phrase, that is this one, AMITABH and BACHAN, CHCHAN. It will suggest this correct term. How it knows? Because it finds that the number of people written this term is very less, whereas number of people written this is very high. The number of hits of this particular term is very much larger than comparative to this one. Instead of performing all this stuff, it can easily suggest that whatever you have typed, maybe it is wrong. it may be this one, because the number of hit of this one is very higher than this one. Anyway, we are concentrating on how to find, we have to find the edit distance in between the different terms or words and to choose the proper word. So how it will help you, or it may not help you. Look at here. Suppose you have the three terms flew, FORM and Heathrow, and to find that in our database of the corpus there are 7 alternatives for this particular first term, and there are 19 alternatives for this particular term second, and there are 3 alternatives for the third term. So can you say what are the possible combination of these 3? Around 17 into 19 into 3, which is very hard or very high or very large. So you cannot suggest this much list, highest number, larger number of list to the user. He or she will bore and he or she will leave that application. He will not, he or she will never refer that particular application which is suggesting this much number of solution or correct phrase, though he or she have been written wrong. Okay. So in that case, what is the another approach that can be done? That is looking the bywords. If there are 3 words, choose the more than 50% of words whether it is matching from the given phrase. Byword means you are considering 2 words, at least 2 words should match, so that I can predict the third word if it is written wrongly. Okay, suppose in this example, flew from Heathrow, I found that whatever the index we have, phrase entry we have, we found that term 1 and term 3 is matching correctly, whereas this one is not matching. So you just suggest that particular phrase instead of all the possible phrases, permutation combination of all the phrases. You should suggest that particular phrase, because we find that out of the 3 terms, 2 are matching properly. It is correct and it is correctly matching in the same phrase entry. Only that one particular term is not matching. You can suggest that instead of this FORM, it may be FROM. That is, you are using the concept of bywords overlap or byword matching. You are assuming that you are finding that at least 2 number of words are matching in between the query in and in your corpus what you have in your number of phrases. So what the issues till now we have found in case of spell correction, that we may have multiple alternatives to suggest the user. We should avoid to suggest several number of alternatives. We just try to suggest, undoubtedly suggest, you have to suggest, because the entry is given by the user is wrong. We have to suggest some correct, but it should not be very large. We should try to show very small number of suggestions. Though there are several possible solutions, out of that which is the best one or which is more frequent, that one should be suggesting. How it can be done? It can be done by a heuristic approach. That is, whoever the alternative, because you have several alternatives for a given query and all are correct, but still you should not suggest all, rather you should suggest very lesser or very it may be only one. Okay, how it can be done? By an heuristic approach, that particular alternative who is hitting highest. How? By number of people or the number of users. Mostly hitted particular alternative can be suggested. And again, how you know which particular alternative is being hitted by more number of people or more number of users? By analyzing the query log. What are the, suppose from 2020 to 2021, which particular terms are being hitted highest by the user, or what the number of by analyzing the query. We found that that particular term CORONA is being highest hit during this year term 2000 to 2021. So that is why if anybody is writing CORANA, then also the user, the Google or the search engine will show the correct response regarding the CORONA, because it found that in this particular year may not be it was happening earlier, or may not be it will happen later also. Currently this may happening because it analyzed the current query log. What are the different numbers of people are doing or asking which particular terms by maintaining the log history. It's nothing but the history. So this spell correction is very computational expensive. We should avoid running this kind of spell correction regularly. We should avoid. Whenever we find that any mistakes are there, at the time we should do that. Otherwise not. Avoid running routinely for on every query. We should not do that. It is very much expensive. Okay. It may happen that the query is wrong. At the time you should do this kind of spell correction, or else you found that whatever the dictionary you have, indexing you have, the terms present in the index in your index is not exactly matching with that given query. In these cases you may do this kind of spell correction, otherwise not.